Hello, good morning everyone. Today I am here with my group members to explain exploratory data analysis with classical and Bayesian analysis. Next slide please. Next slide. Now we will see what is data analysis. So data analysis is mainly used by data scientists or data analyst or anyone in the data field to analyze and investigate their data set. It helps us in summarizing their main characteristics and the and it helps us see beyond the data. It helps determine how best to manipulate data sources to get the answers you need. Basically, it is the solution to all our data problems. Data analysis makes it easier for data scientists to discover patterns in the data, spot trends, spot anomalies, test a hypothesis, or check assumptions. Next slide, please. Now we will see the importance of EDA or exploratory data analysis. The main purpose of data analysis is to help look at any data before making any assumptions. Data scientists can use the exploratory analysis to ensure the results they produce are valid and applicable to any desired goal, business goals, and outcomes. It can help identify obvious errors as well as better understand patterns within the data, detect outliers or anomalous events, find interesting relations among the variables. Exploratory data analysis is very helpful in our lives because it helps us visualize data, and visual data is far more better and understandable than the data. Now I would like to give Abhishek.
Thank you, Arya. Next slide, please. So, comparison of EDA with classical data summary measures. So, first of all, when it comes to comparison between classical data and exploratory data analysis, the first most thing that we see is like what is data analysis in terms of both of their respective measures. So, in case of classical data analysis, data analysis is like finding trends in data through generally with the statistics and probability and the data set that is required. Also, data analysis like helps in sorting out the real trends from noisy data in case of classical data analysis. And here, the noisy data refers to like irrelevant data or like some uh, irrelevant data in a data set that is referred as noisy data. On when it comes to exploratory data analysis, here uh, the data analysis actually means it's an approach for like analyzing the data using different techniques. Not just using statistics or probability and using different techniques such as like maximum insights into data sets, extracting important variables, detecting outliers and anomalies, also testing underlying assumptions. So one of the main difference comes in both of the analysis is like the sequence following the analysis sequence. In case of classical data analysis, the sequence follows as first we find the problem, then we collect the data. After that, we reframe the model and then we perform the analysis and then we arrive to the conclusion. But in case of exploratory data analysis, we detect the problem, then we collect the data. And after just collecting the data, we perform the analysis and then we reframe the model. And after that, we arrive to conclusion. Here, just the difference comes that after collecting the data, we create the analysis. In that case, we not just only like identify different trends and insights, like it actually helps in reframing the model much better and arriving at much accurate conclusions in comparison to classical data analysis. Next slide, please. Here comes the techniques for analyzing data between same as difference between classical and EDA. So in case of classical data analysis, the classical techniques that are generally are quantitative of statistical procedures that yield numeric or tabular output in nature. As I said earlier, like in case of classical data analysis, it is regarding done with the help of statistical and probability measures. So some of them include like ANOVA, t-test, t-square test, and f-test. So these generally take the data sets and then they perform the analysis and they give the desired values. Whereas in case of exploratory data analysis, most of the techniques are generally graphical, which gives us a more clear and accurate view of our data that we are going to analyze. So some of them include scatter plots, histograms, box plots, residual plots. Here the advantage of the graphs are like, as I said earlier, when it comes to statistics and probability, we just get numbers and we can also say little accu- accuracy or value compared to EDA analysis. And in case of this graphical representation, we can also see the linearity of our data, the how much accurate the data is, also the different anomalies that are present in our data. We can even detect them and remove them. And we can also identify much different number of patterns and trends as compared to classical data analysis. So this was all the difference between both the data analysis pattern. Now I would like to hand over to my friend Apurva. Thank you.
Okay, so my name is Apurva, and today I'll be comparing EDA with classical and Bayesian data analysis techniques. So, in classical data analysis techniques, the importance is given to model development as compared to data analysis part itself. So, the steps involved in classical data analysis is that first we create a problem definition. Based on the problem definition, data collection is done. After that, model development, data analysis, and result communication is done. So in data analysis part, we do some data cleaning, data pre-processing, and data visualization in order to get a better understanding of what kind of data we are dealing with. The exploratory data analysis is kind of similar to classical data analysis itself. The only difference is that instead of focusing more on model development, we focus more on data analysis part. So as you can see, the main structure, the main focus is on understanding the data, its structure. If it's not in structure, we usually put it in some formalized structure. We detect outliers in that data, and then we create some visualizations. So in EDA, we generally don't impose any deterministic or probabilistic model upon our data. The Bayesian data analysis is kind of different as compared to both of them. So so here we have an additional step of creating a prior probability distribution between model development and data analysis steps. So the Bayesian approach basically incorporates priority probability distribution into our analysis step. So this probability distribution can give expresses the belief about the particular quantity before even considering some evidences. Now you can see a graphical representation of both the data analysis approaches. So as you can see in classical data analysis, the model development step is done first, and then the data analysis steps comes the next one. In exploratory data analysis, you can see these two steps are being switched up. The data analysis part is done first, and after model development is done. In Bayesian data analysis, you can see that there's an additional step of prior probability distribution between model development and data analysis part. So that's it for today's slide. Thank you and have a nice day ahead.